In this video, we'll continue our discussion of vector fields by doing a matching exercise here. Notice we have 8 different vector fields and 6 functions. There's a point in that. Some of them are going to be the same. Before I start, I'm going to go ahead and figure out, we have, if you look at E through H, they want us to find the gradient vector field given the potential function they gave us. So if I'm finding, I'm going to go ahead and list these out because they're probably the same as the ones above. I got 2x, that's the derivative of f with respect to x, and 2y. Now this one is going to be a little messy here. I'm going to go ahead and let you calculate this, but what ends up happening is we get x over the square root of x squared plus y squared. And then we get the same thing but with y. Alright, this is just a unit vector. Okay, this one, I get the gradient is equal to yx. And then the last one, I got f is equal to, it's going to be 2x and negative 2y. That's the same as d. I'm going to list these out because I don't want to have to think through them every time, which one's the same or not. So I'm just going to put them next to each other. Okay, I got a by itself. There is no match a. B and g are the same thing. C is by itself. D and H are the same thing. And then we have E and F that are different. So notice that's 6. We have 6 graphs. These are going to match up. I have a technique for these. You may have another way that you want to think about it. That's fantastic. Just make sure it's something maybe you can write down and project to me that you understand. So let's begin. So this is how I approach these. Is I'm going to take this vector field and I'm just going to think about the signs in each quadrant given my vector. Now this is a little confusing because the way they label it, the I component says 1, so I know my I component and my vector is going to be positive always in quadrant 1. Now in quadrant 1 I'm looking at my y and I can see the x there, okay. X in first quadrant is positive, so the j component, since the j component is x, this is also going to be positive. This is going to give me arrows that point up like that, to the right and up. Right, now I'm going to go down and do the same thing. I know this is positive. We could just really write 1 here if I wanted to. These are 1s. Those aren't even going to change ever. And then it's still based on x, so it looks like that. X is positive, so the j component is going to be positive. Okay, I get a 1 here. X is negative in this quadrant, so the j component's going to be negative. And then the same thing down here. So these go up but down. To the right and down. That's better. To the right and down. So I'm looking for a graph that looks like that. We only have one option in our list. This option is 2. Right? All the vectors are pointing in the same way. Now the magnitudes change, and that's fine. And we could think about that. As the x gets out here, these get bigger, right? That makes sense. And same here, as x goes away, that's going to be a negative x. It's going to make a bigger incline. So I use this method on each one. It seems to work with matching pretty well, especially in 2 dimensions. 3 gets a little trickier. All right, so let's do this one. All right, so this is weird. The y in the first component is positive, so the I component is positive. X in the first quadrant is positive, so the j component is positive. So these arrows are going to look like that, those vectors. Down here, okay, the y in quadrant 4 is negative, so the I component is going to be negative. And then the x is positive in quadrant 4, so the j component is positive. So this goes to the left and up. Okay, this one. The y up here is positive, so the I component is positive. X is negative, so j is negative. This is going to the right and down. I'm going to get rid of this arrow so it doesn't throw me off. This one. Okay, I know the y component is negative down there, y is negative in that quadrant, so the I component is negative. And then the x is positive. This is going that way. All right, so we get some kind of understanding of what the vectors are doing. It's going to at least allow me to mark off some. I know it's not 1. It's not, we already used 2, so it's probably not 2. No, this kills 2, right, in that quadrant. The third, number 3, this doesn't do what we said it would do up there. Okay, I'm going to zoom out. Now, this doesn't do exactly what we said this would do up here. Okay, this one, though, looks like matches all of my vectors in my sketch up there. I just need to make sure 6 doesn't do it as well. It does not. So this is 5 for B and G. Right, we're going to do the exact same thing for C. Right, so negative y, well, y is positive, so this is going to be negative in the I component. X is positive in this quadrant, so it's positive. That goes down and, or left and up. There we go. Okay, the next one, negative y, it's the same thing, but now x is positive, so this goes down. Right, y is negative, so this is going to be positive, and x is still negative. So this goes up, to the right and down. And then the last one, the y in this one is negative, so that makes this positive, but the x is positive, so with that you can see this is rotating. So C is going to be vector field 4. Cool, we got one more, or a couple more, sorry. All right, if we take a look at this one's very easy to do. 2x minus 2y. Okay, I know it's positive, and then it's going to be negative. Then it's going to be negative, and then negative, negative, and then positive, and then negative, positive, positive. That's just looking at here in the quadrants of the signs. So this goes to the right and down. This one goes to the right and right. This one goes left and down. This one goes left and up. So it looks like they're approaching the x-axis. We only have one that does that. The only one that approaches the x-axis from both sides would be field 1. Right? I hope this is feeling easier for you. Okay, this one, we can just think about that one. That one's expanding out. As x and y get bigger, everything's going to be going away. We could draw another one of these. This is a little easier to see. What makes it nice is x is in the I component, y is in the j component. They're both the sign. I could even factor the 2 out there if I wanted to. I could say 2xy. xy is a, what we call, I think, radial. It goes out away from the origin. So we have 2 of those. We have 3 and 4. Now the thing is, as this gets bigger and bigger, we're looking at this vector, the length of the vector is also going to get bigger. Well, if we look at 3 and 4, 4 does that. As we get away, the vector gets bigger. That's going to respect this idea that as x and y get bigger, a vector magnitude is going to get bigger. So E is number 4. Leaving F with 3. This makes sense. It's radial, goes out away. The square root of x squared plus y squared is a magnitude, which means we're making a unit vector. If you look at all the vectors in field 3, they look like unit vectors. They're all the same size. Definitely not 6, where 6 is getting bigger as we're going out. I think I may have called that 4 just a second ago. Forgive me. Roman numerals, I don't know why we're still using them, but they work.